All right, so let's go review solving right triangles. And so here I have a picture of a right triangle. Angle B is my right angle, or my 90-degree angle. And if I want to find the sine of angle A, typically we just write sine, S-I-N. Okay, so sine of angle A, and my angle is going to be in parentheses. Okay, so this is whatever's on the inside is called the argument. Okay. And if you remember from Math 2 or geometry, right, sine of angle A, right, is opposite over the hypotenuse, right? And so the hypotenuse is always going to be side that's opposite the 90-degree angle. So that's going to be AC. And the opposite side of angle A, right, here's angle A. The opposite side would be side BC. Okay, so your sine, right, is defined as opposite over hypotenuse. This is something I would memorize, okay, the definition. Because every single triangle is labeled differently, so I would not just memorize BC over AC. Okay, so memorize the definition. And then, of course, cosine, right, if you spell out the whole word is C-O-S-I-N-E, but typically we abbreviate, we say cos, right, or C-O-S of angle A. And if you remember the definition, right, it's adjacent, I'll just abbreviate, adjacent over hypotenuse. Adjacent just means next to, okay? So if you wonder what that word adjacent means, it just means next to. And so here's angle A, right? You could say, well, isn't AB and AC next to angle A? And strictly speaking, I would say, yeah, they're both next to angle A, right? But the hypotenuse is never the adjacent or the opposite side, okay? So the hypotenuse is always hypotenuse. So that means the adjacent side has to be AB, okay? And the hypotenuse is always the hypotenuse. So again, the word adjacent means next to. And then, of course, tangent, right? In the full writing of the word tangent, you spell it out as tangent. But we abbreviate when we memorize or we write it out mathematically. Tangent of angle A is opposite over adjacent. Okay, so opposite over adjacent. The opposite side is BC, and the adjacent side in this picture is AC. AB, I should say. AB, right, is the adjacent side of angle A. Okay, so, you probably memorized this, right, already in Math 2, but if you haven't, right, this is the acronym, sohcahtoa. If it helps, you don't have to use it if you already know your trig ratios, right? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent, right, is opposite over adjacent. Okay, so that's where sohcahtoa comes from. This is only if it's helpful if you're having trouble memorizing. Okay, so we're going to use these three trig ratios in solving right triangles. Okay, so let's take a look at problem number 2 in your notes. Solve the right triangle just means find all the missing sides and all the missing angles. So this is 11, this is 23 degrees, and this is x. Okay, so solve the right triangle. Okay, it means find all angles and sides. Okay, so right now, if I want to figure out what this angle is right here, right, I could do 80 minus 90 minus 23, which would just give you 90 minus 23, which is going to give you 67 degrees. Okay, so I figured out all my angle measurements in this triangle, and I'm given I'm given a side x, right? And I also need to figure out what this is. So it doesn't really matter how you want to approach this problem. I would figure out what x is first, okay? And again, there's multiple ways of solving this problem. So if I want to figure out what x is, right, and I know that this is 23 degrees, in relationship to the 23 degrees, right, I'm given an adjacent side, and I need to figure out what the opposite side is, right? And so this is adjacent, right, to 23. This is opposite to 23, okay? So if we're using the angle 23, right, relative to 23, 11 is the adjacent side, x is the opposite side. So what trig ratio are we going to use? Well, opposite over adjacent, right, you look at your notes, it's clearly going to be the tangent ratio, right? So I'm going to say tangent of 23 is equal to opposite over adjacent, okay? So if you cross multiply, right, x is equal to 11 tan 23. This would give you the exact answer, okay? But the problem is asking you to find the approximate answer. Now on a quiz or test, you need to be comfortable of writing both the exact and the approximate, okay? So if you enter it on your calculator, if you round it to the nearest tenth, 4.66, which is around 4.1, right? If we round it to the nearest tenth. Okay, so this is called the approximate, and this is called the exact answer. So on a quiz or test, I may ask you just to give me the exact answer, right? You don't need a calculator. It shows that you still know the concept. So this is one way of figuring out what x is. And, let's say you need to figure out what the hypotenuse is, right? Maybe we'll call this, we'll call this side, instead of calling it question mark, maybe we'll call it r, okay? So how do you figure out what r is? Well, if you want to figure out what r is, in relationship to the 23, right, you're given the adjacent side, which is 11. This is always going to be the hypotenuse. You can solve by using cosine, right? Because cosine relates adjacent versus hypotenuse. So I'm going to say cosine of 23 is 11 over r. And if you want to get r by itself, right, you have to cross multiply. R cosine 23 is equal to 11. R is equal to 11 over cosine of 23. Again, this is the exact answer. Okay, this is the exact answer. And then the approximate answer is where you enter it on your calculator. So 11 divided by cosine of 23. Make sure your calculator is in degree mode. It's approximately 11.9. Okay, so this, I want to encourage you to show you that this is just one way of figuring out what x is, figuring out what r is, using angle of 23 degrees, right? If you want to use 67 degrees, right, you could also solve the triangle getting the correct answer, okay? So I'm just going to show you this one way. Is there a preference, Mrs. Zhu, like you did for chapter 6? No, there's not a preference, okay? The other way, if you use angle 67, right, and, solve the right triangle that way, that works as well, okay? What if you know x already, Mrs. Zhu, and you know 11? Can't you just use Pythagorean theorem and solve for r? You can also use that, because in geometry, in trig, there's multiple ways of doing the same problem. One way is not necessarily easier than the other way, as I mentioned. It's unlike chapter 6, right, where I showed you how to simplify the complex fraction. One way is clearly easier than the other. All right, so if that example didn't quite make sense, let's move on to number 3. And here is a right triangle again. And this is 16, and this is x, and this is 62. Okay, so again, they want you to solve the right triangle, so figure out all the missing angles, right? This is just going to be 180 minus 90 minus 62. So 90 take away 62, you're just going to get 38 degrees. Okay, so again, when solving the right triangle, you could use the 38 degrees or you could use the 62 degrees, right? It doesn't really matter. I'm going to call this, I don't know, I'm just going to call this A. So let's say we want to figure out what x is first, right? And we're going to use the 62 degrees, okay? So using the 60 degrees, because you could use the 38 degrees or the 62 degrees in solving your right triangles. And you're given this, right, in relationship to the 62. Now, this guy right here is the hypotenuse, right? And the 16 in relationship or relative to the 62, right, is the opposite. And so when you have opposite and you have hypotenuse, you're going to use the trig ratio of sine. is equal to, sine of 62 is equal to 16 over x. When you cross multiply, you get x sine 62 is equal to 16, and get x by itself, 16 over sine 62. So this will be correct. This will be your final answer. Let's say you forgot your calculator or you don't have a calculator and you just wrote this. You understood the concept, you just need to enter it on your calculator. Okay, so again, this is called the exact answer. And then an approximate answer, you enter it on your calculator. 16 divided by sine 62. I'm going to enter on my calculator. I'm going to get 18.1. Okay, so this is the approximate. All right, so again, I want to emphasize this is just one way of solving for x. Could you have used, just to show you what I mean, what if you used the 38 degrees, right? If you use 38 degrees and you want to solve for x, the 16 is adjacent, right? So you could have said cosine of 38, right? Because this angle is 38 degrees. Adjacent would be 16, right? And then over hypotenuse, which is x. X is equal to 16 over cosine of 38. You'll get the exact same answer, okay? So this one I'm not going to be picky on, right? Whether you want to use angle 62 or angle 38, right? One way is not necessarily easier than the other way, right? It just depends which angle you use, okay? All right, so, solving the right triangle, I still need to figure out what A is. So again, let's use 62 in relationship to the 62 degrees right here, right? A is next to, right? This would be adjacent. This side right here is adjacent to 62. And this side right here, right, is the opposite of 62. And so when you have opposite over adjacent, right, you're going to use tangent. So I'm going to write tangent of 62 is equal to opposite over adjacent, so 16 over A. And then cross multiply and get A by itself, 16 over tan 62. And figure out what that is in your calculator. 16 divided by tan 62, about 8.5. Okay, so again, this is the exact, this is the approximate. Okay, so that's how you solve the right triangle using your sine, cosine, tangent on problems 2 and 3 in your notes. Okay, so let's take a look at 4 and 5. 4 and 5 are a little bit different. They want you to find the missing angle, okay? In the sense that you already are given all three sides, right? If you use Pythagorean theorem, you should see that this relationship works out, right? 70 squared is equal to 42 squared plus 56 squared. But they want you to find what this angle is, okay? So I'm just going to label it, even though they don't quite label it for you. If I want to figure out what angle A is, I have many, many options, right? I could use sine, cosine, or tangent. It doesn't really matter because I'm given all three side lengths. And so let's say I just want to use the 42 and the 70, okay? Well, then you would say the sine of... if I want to use the 42 and 70, I would say the cosine of angle A is equal to adjacent, right? Adjacent side would be AB, which is 42, over the hypotenuse. The hypotenuse, of course, is 70. So this ratio is true, but I want to figure out what angle A is, right? So you need to take the cosine inverse to get angle A by itself. You need to take the cosine inverse of 42 over 70. Okay, and then enter this on your calculator. You should see a -1 button. It doesn't mean negative exponent, it just means inverse. So typically on your calculator, you should see a second button, and then you hit the cosine inverse. Okay, so that's what I have on my calculator. Again, I know it's a little bit hard, distance learning and whatnot, but you should see a second button, and then you hit the cosine inverse. So 53.13 degrees is what I got over here. Okay, it didn't say which number to round it to, so I'm just going to round it to the nearest hundredth. So why don't you try number 5 on your own? See if you can come up with the answer of this particular angle. And I would just label it, even if they don't give you any letters. See if you can figure out what that angle is. Again, I would just pause this video and then try it on my own, and then resume the video when I go over the answer, when you got your answer, you can resume it and check it. Okay, so again, I will label it. I'm going to call this A, B, C, and I need to figure out what angle C is, right? And this time, relative to angle C, they only give you two sides. Now, could you have figured out what AC is using Pythagorean? You could, but I'm not going to do that. That's just extra work. So in relationship to angle C, right, I'm given a side that's opposite. I'm given a side that's adjacent relative to angle C. And if I have opposite or adjacent, I know my trig ratio has to be tangent, right? So tangent of angle C is equal to opposite over adjacent, 5/9. And to get angle C by itself, right, because C is in the argument right here, C is equal to tan inverse of 5/9. And you enter that on your calculator. You're going to get about 29.05 degrees. Okay, so that's what you should have gotten for number 5. All right, there's one last problem, and that last problem is the vaunted word problem. Okay, so before I move on to word problems, I just need to review briefly with you, the angle of elevation, angle of depression. Okay, so, let's say a person is looking up, okay, right here, he's looking forward. This is the horizontal, okay, where he's looking straight across, and then he's looking at an angle at some top of a cliff, okay? So here's another person right here, and he's on some kind of cliff right here, okay? All right, well, the angle that's formed between the horizontal and to the person here on top, this is called the angle of elevation, okay? And that makes sense, right? When you look at the top, from the bottom on the ground, right, this angle right here, we'll call it angle of elevation. We'll call it theta, okay? Theta is called the angle of elevation. Okay, well, at the same time, right, this person also has a line of sight, okay? The horizontal, something called the line of sight. This person's looking down, and the angle between this diagonal and his line of sight, or his or her line of sight, this is called the angle of depression, okay? That's called the angle of depression. We'll call it beta, okay? That's the angle of depression. So it's really important for you to know that vocabulary. Otherwise, as you're doing the word problems, you're just going to have trouble drawing the picture, okay? So if you remember, right, these lines right here are actually parallel, right? Beta is the angle of depression. And if those lines are parallel from geometry, right, arrow mark, these angles right here are congruent, right, by alternate interior angles. So theta actually equals beta by alternate interior angles, okay? So that's one of the main things that you have to remember from geometry, right? If I have two parallel lines, right, this angle right here and this angle right here, 1 and 2, are congruent by alternate interior, okay? And that's what you have over here. Your angle of elevation, your theta is equal to beta. These two lines right here, the line of sights, are your horizontals, and then this right here, this diagonal, is like basically your transversal, okay? So just be familiar what they mean when they say angle of elevation, angle of depression. This is how you would draw it. And typically that's how it's defined in a math textbook, okay? So let's take a look at number 6. Your last word problem of the day, or your last problem of the day. It says you are standing on a plateau, point A, that is 800 feet above a basin where you see two hikers, B and C. B is closest to you and C is the furthest. All right, so you are on some kind of plateau, right? And this plateau is 800 feet. Okay, so 800 feet. All right, so I'm assuming this is you right here, okay? So we'll say you is right here at this tip. And it says you see two hikers, B and C. B is closest to you, okay? So angle B, here's the point B. All right, it says if the angle of depression from your line of sight, right, this is you, assuming this is your line of sight, to hiker B, this is hiker B, is 25 degrees. So that means this angle right here is 25, right? And I just explained to you that if this angle right here is 25, right, which is the angle of depression, this angle right here, which is the angle of elevation from the hiker's vantage point, is also going to be 25 degrees, okay? Because alternate interior angles. So how far is the hiker from the base of the plateau? Well, once you have the picture on part A, right, how far is the hiker from the base of the plateau? You already know that this is 800 feet. That's the height of the basin. And hiker B is right here, right? You're just trying to figure out what X is, right? And so if you have a side that's adjacent, which is X, and a side that's opposite, you're going to use your cosine ratio. So cosine, a side that is opposite and a side that's adjacent, you're going to use your tangent ratio, right? Relative to the 25 degrees, this is the opposite side. And then relative to the 25 degrees, right, this X right here is adjacent. Okay, so we're going to use tangent, not cosine. Tangent of 25 is equal to opposite over adjacent. Okay, and then you solve this one-step equation, right, by cross-multiplying. And you get X by itself. X is 800 divided by tan 25. 800 divided by tan 25, you're going to get approximately 1,715.6 feet. Okay. All right, so continue on in part B. It says if the angle of depression from your line of sight to hiker C is 15 degrees, right? C is a little further out. So let's draw something to hiker C. So here's hiker C, right? And they said from here to here is now 15 degrees. Well, from here to here is 15. That means from here to here is going to be 15, right? Again, alternate interior angles. So how far is hiker C from the base of the plateau? So maybe call this guy right here, call it Y. I know you have a lot of lines right here, but basically you have just one right triangle, right? The opposite side is still 800, the adjacent side is Y. So you're still going to use the tangent ratio, right? So I would say tangent of 15 degrees is opposite, which is 800, over adjacent, over Y. I mean, you don't have to use the units right here as you're solving, so you can erase that degree symbol. Okay, so get Y by Y is equal to, I'm going to skip a few lines, Y equals 800 divided by tan 15. Okay, and then enter it on your calculator, 800 divided by tan 15. Okay, so you're going to get 2,985.64 feet. Now, that makes sense, right? It looks like Y is definitely greater than X. And so if you have a number that's smaller than X, right, you probably did something wrong. Okay, so that's hiker C's distance to the base of the plateau. We just figure out what Y is, right? And then part C asks how far apart are the two hikers, right? Well, if you know the distance from C to, maybe we'll call it E right here, is 2,985 feet, and the distance from B to E is 1715.6. BC, right? The distance from B to C is just Y minus X. Okay, so Y minus X will give you the distance between the two hikers, 2985.64 minus 1715.6. And you will get about 1,270.04 feet. Okay, so the key on these word problems right here, you'll probably see a couple in your homework, is to be able to draw the picture and then use one of your trig ratios, sine, cosine, or tangent, to solve.